Welcome. In this video, we will be going through finding the volume of solids, also known as three-dimensional figures. Right? Volume is nothing more than the measure of the space inside of a three-dimensional shape. Let's start with prisms. When we look at prisms, in order to find the volume, we have different formulas depending on the type of prism. For example, this first solid is known as a rectangular prism due to the fact that the base of the shape is actually a rectangle. In order to find the volume of this particular solid, we multiply the length by the width by the height. The 6 inches would be our length, our width would be the 4.5 inches, and the 5 inches would be our height. Substituting this into our formula, we have 6 times 4.5 times 5, leaving us with a volume of 135 inches to the third power, or inches cubed. Anytime we work with volume, our units will be cubed. The second prism that we see here is different because our base shape is actually a triangle. So this is known as a triangular prism. Alright, now the difference here is in the formula. We're still finding the area of the base shape, which in this case is going to be using the formula for the area of a triangle, which would be your length times your width divided by 2. So we have 6 times 8 divided by 2, multiplied by the height of the solid, which in this case is 9. 6 multiplied 8 divided by 2 is going multiplied by 9 will give us 216. And in this case, our units are meters to the third. The formula that's on your formula sheet looks something like this. Anytime we see a capital B in a volume problem or a volume formula, it's talking about the area of the base shape. That is why I was able to figure out that it's 6 times 8 divided by 2, because we were finding the area of this base shape, which was the triangle. Let's move on to cylinders. Cylinders have a very unique formula. In order to find the volume, we are looking at a formula of pi times r squared times the height. Notice, once again, what we're really working with here is the base shape and its area multiplied by the height of the solid. The base shape of a cylinder is nothing more than a circle. And to find the area of a circle, it's pi times the radius squared. In this first example, we're not given a radius, we're instead given a diameter. So we go ahead and find our radius, divide your diameter by 2, leaving us with 4 centimeters. So, to find the volume, we have pi times r squared times h, or pi, which we put in as 3.14, multiplied by 4 to the second power, multiplied by the height of our solid, which in this case is 9. It's a simple order of operations problem from here. You can pause the video for a moment, double check your calculations. What you should end up with is 452.16, and don't forget the units are to the third power. Go ahead and pause the video and attempt the next one on your own. Okay, once again, we're using our volume formula, pi r squared times h. In this case, we're given a radius, and we're also given our height. So let's put those in. We have 3.14 multiplied by the radius of 1.2 squared multiplied by the height of 8.3. Now this one ends up being a very, very long decimal of 37.52928. Be careful with problems like this. Make sure you read the directions very carefully. It'll tell you exactly which decimal place to round to, or if it does not, make sure you list the entire answer. Let's move on to cones. Now, of course, we've all seen a cone before. And if you have already watched the video on 3D Nets, you'll have already figured out how to make a cone out of a piece of paper. Formula for a cone, in order to find the volume, is a little bit unusual, as it has 1/3 pi r squared multiplied by the height, and that's going to give you your volume. So if we look at this first cone, we're given 3 numbers, but we only need 2 of them. What we need would be the radius and the height of the solid. This 13 is a slant, and we do not need it. Not for this formula. We will need it for surface area, but we don't need it here. Let's go ahead and put our numbers into the formula. We have 1/3 multiplied by 3.14 multiplied by the radius squared multiplied by the height. Pause the video and try the calculation. Okay, when you finish calculating this out, you should end up getting 314. Now in this case, we did not have any units on our actual problem. So just to be a little bit overcautious, we're going to write units cubed. All right, and this would be our answer. Pause the video and see if you can substitute the numbers into the formula correctly for this second example. All right, when you do so, you should end up with the volume is equal to 1/3 multiplied by 3.14 multiplied by 10 squared multiplied by 24. The 26 is not needed here because that's a slant and we're working with volume. The 20 is a diameter, thus cut it in half to get our radius and the height of 24. Go ahead and pause the video, see what you get as your calculations. All right, when you multiply this fully through, you should end up with 2,512 millimeters cubed. Notice that all we're really doing here is practicing a skill that we worked with back in October, which was substituting numbers into an expression and evaluating it. Right? We did this order of operations with substitution. The difference here is that we have a specific formula for each individual type of shape, or each individual type of solid. Let's move on to pyramids. So pyramids are a little bit more confusing. They go back to that idea of using the capital B, which, as we said before, is nothing more than the area of your base shape. The reason this gets confusing is because you really have to pay attention to the shape that is sitting as the base of your pyramid. For example, in this first pyramid, we actually have a square as our base. And the reason we know that is because the sides are equivalent. Whereas in our second pyramid, because of the shape that we're given, because of the measurements that we're given, we know that this is actually a rectangle as our base. So we would use our formula to find the area of a rectangle to substitute for B. In the third shape, we no longer have a square or a rectangle. Instead, what we have is a triangle. So once again, use the formula to find the area of a triangle and substitute that for your capital B. Let's take a look at the first pyramid again. We are looking to find the volume. In order to find the area of the base shape, since we're dealing with a square in there, we square our side length. 7 to the second power would give us 49. And we multiply this by the height of our solid, or our pyramid in this case, which happens to be 10. When we multiply this out, we end up getting 163.3, repeating, millimeters cubed. Okay? Attempt the second problem on your own. Pause the video. Okay, hopefully you recognized that in order to find the area of the base shape, since it is a rectangle, you're looking at base times height, which means you have 8.4 multiplied by 12.5, giving you 105. We multiply this by the height of our pyramid, which would give us an answer of 255.5 meters cubed. And that is our volume. Attempt the third one on your own. Once again, pay close attention to your base. In this case, it happens to be a triangle. And the two dimensions that we will use for the triangle are 18 and 22. When you substitute those into the area formula for a triangle, you'll end up getting 18 times 22, and that product divided by 2, which would give you the area of that triangle, working out to be 198 inches squared. If we multiply that by 1/3 and by the height of our pyramid, we can get the volume of our pyramid here, which happens to be 858 inches to the third power. Hopefully this video helped you to see the use of our volume formulas for our three-dimensional figures. You will have a worksheet that accompanies this. Please complete that. If you do not have a copy of your formula sheet with you, you are welcome to pause the video at this screen so that you have all of the formulas accessible to you. From here, we'll move into surface area, which will actually end up using all the other formulas you see here that say S dot A dot.